All right, ladies and gentlemen, this class recording has started. So, as you can see up on the board, the first part of this section is called the Introduction to Mechanics. And mechanics is the study of motion. When we start talking about things in, like I said, the big macroscopic world, if we want to talk about that, right? Microscopic being small things, macroscopic being big things, right? The first thing we talk about is motion and describing the motion of an object. What we find is that in the course of describing the motion, there are four things that we want to talk about. And those four things are as follows. So, if we can answer these four questions about an object, we have done a thorough job of describing its motion. So the first thing we want to know about an object is, where is it? The second thing that we would like to know about an object is, what is it doing right now? The third thing is, what is it going to be doing in the future? What's going to happen to it next? Is it going to stay the same? Is it going to change what it's doing, etc.? And then the fourth thing that we talk about, or the question that we want to answer, is when? When do all these things happen? Like I said, if we can answer these four questions, we do a good job of describing the motion of an object. Okay? Good there. Okay. First, I'm going to skip over this picture of this iguana. We'll come back, okay? And I want to address the first question, because it's the first question. So, I'm going to go out on a limb here, all right? And I'm going to say, what you're about to see is probably going to be the best thing you see all day, right? I'm going out on a limb, but I'm pretty sure it's the best thing you're going to see all day. No. No, this is the tangible world, remember? Like real things. No. Alright, so in my hand is an Einstein action figure. Don't call him a doll, he's an action figure.
It's got a diaper on.
Get real, it's a doll.
It's got a sweater on. Well, so first off, okay, this Einstein action figure was given to me by a former student, okay, who I just want you guys to know went to college and now currently is a physics teacher. So dreams can come true, everybody. All right, just so you know, right? You know, so nobody you would know. So I don't want to. No names, please. Like, because
I just don't want to. You can pass it over.
I just want you to know it exists. So, no. So he got it for me. He got it for me at Big Fun. Has anybody ever been to Big Fun before? Right? It's like a crazy toy store. Like, you know, it's got weird things like Einstein action figures and stuff like that. You know. So but he's got he's got a little piece of chalk in case he needs to do any calculations real quick, right? But one of the things that has happened over time, because now that the person who gave it to me is now a physics teacher, it's been about, I think, 7 years or so. One of the distinctive features of the Einstein action figure is his hair, obviously, because, Einstein, right? But through the passage of time, the glue that holds Einstein hair is not as strong anymore. It's like an android. He's like a robo Einstein. So we'll just put his hair back on. Yes, that's true. So true. So anyway, like I said, probably the best thing that you're going to see all day. All right. So I'm just gonna put it down right here, so we can stare at you guys. So this. Hey.
Eddie, don't break this.
All right. So Einstein action figure leads us into the first question. So as Audrey's doing right now, okay. Like I said, probably the best thing you're going to see all day. So you get your phone out, right? Text your friend.
Friend.
You'll never,
Friend number
because
one.
you guys all start texts with dear friend, right? Dear friend. And sign it. Yeah. So, dear friend, never guess what I saw today. Einstein action figure. Coolest thing ever. And then probably put like an emoji at the end, right? Something. If there was an, is there an Einstein? Yeah. But I think actually to capture the moment, probably this would be better.
No, I didn't want to put the heart eyes. Be like, I love it.
Maybe that. Anyway, so maybe yeah, like you know. So all right, so because I know the kind of people that you are friends with, right? Your friend would write back and say, "Cool." Period. I have to see this. Where is it? So you would answer that question. Well, if you answer with Mr. Planasec's room, we run into a problem because this person, well actually I don't have many rooms, I only have this room. But this person, right, well that's true, right? So, okay. That's true. I'm glad we remembered that from before break. That's actually the most important lesson of the entire year.
Don't come to my house.
Don't ever come to my house.
There's a whole bunch of these dolls.
I swear.
I have like a
You have like
I
a
know.
maze.
I have like an Einstein garden
Bottle
gnome.
about it.
Wow. Now we know where to find you. Wow.
Instead of the little underground railroad guy, I have Einstein holding a little lantern. All right, that's untrue by the way. Just so you know.
Oh, it's not?
But anyway, you could answer it with Mr. Planasec's room, which would be fine unless this person didn't have me for class. But even within Mr. Planasec's room, you could say, what? Or has been in this building before, right? Or even if they do have me for class, you could say, well, it's sitting on the desk in front of Audrey, which would be fine, but not everybody knows where Audrey sits, right? So, to answer this question of where is the object, maybe it's not as easy as it seems. So the answer to this question of where is the object, we refer to as the position of an object. The separation between the object and some reference point. Those descriptions of where Einstein action figure is, Mr. Planasec's room, or on the desk in front of Audrey, only work if you know the context in which we're describing it. Everybody in this room, if they said, oh, look, on the desk in front of Audrey, it's an Einstein action figure, people would know where to look because they know where Audrey sits. But people who don't know where Audrey sits don't know where to look, right? So that context, or making sure we're all on the same page, is what we refer to as the frame of reference or the coordinate system. How we describe motion or how we study motion depends on where we study it from. Let's say first day of school next year, you meet a new friend. And after a while, you think, hey, maybe we should hang out sometime. So friends, so, right? Hey, let's hang out. So you have to give your friend, your new friend, directions to your house. You can hang out. But in order for you to give directions to your friend to get to your house, what do you need to know first? Not to give directions, you don't. Well, you know what your address is. You need to know where their know what their address is or where their house is. So you can give. Well, if you're going to give them directions to your house, you need to know where they're starting from.
You can't just have Google Maps or something.
Well, that's a good thing. Google Maps, right, or even Or even if we go big picture, right? If we go Google Earth, right? You pull up Google Earth on your phone or on the computer, right? And the first thing it shows you is a picture of the Earth, right? But what's the first thing that you have to do to make Google Earth work? What's the first thing everybody types in? Yeah, your house, right? You type in your address so you can see like what your house looks like, you know. And
There's like your dog
and-
in your front yard.
yeah,
You never see it.
yeah, because you never see it. At least not from space, you know. I mean, and Google Earth, it's like a paradise, right? It's always sunny, right? Never dark, right? It's like a it never snows, right? It's like a paradise. But again, same thing though. Unless we get everybody on the same page, describing the location of something is hard to do. So the frame of reference or the coordinate system is how do we get everybody on the same page? And in order to do that, we need to set ourselves up first a reference point. Sometimes that reference point could be the starting point of whatever directions we're trying to give. But it doesn't necessarily have to be. Like we go back to giving your friends directions to your house, right? If your friend is maybe describing where they live so you can give directions, but you're not picturing it in your head. So you could just be like, well, hey, do you know where Sweet Basil is? And your friend could say, yeah. You could say, okay, go to Sweet Basil, and then you can give directions from Sweet Basil, right? So, but like what I'm saying is, right, the reference point doesn't necessarily have to be the starting point, okay? And then a directional system is to keep everybody on the same page, right? Depending on where we're measuring things from, we have to distinguish this way from that way. Like the next example. So, what? Could be, but it doesn't necessarily have to be that detailed. We'll see that in a second.
How do I get in trouble for that?
I mean, it could be that detailed, but it doesn't necessarily have to be. That kind of gets at Jillian's question. Like, it could be north, south, east, and west, but it could be something. It could be this. Right? So let's say, right, describing the position of something is great, unless this happens.
Which way is moved?
Okay. Giving your friend directions to get to your house is great for hanging out as long as what? As long as
House don't move.
your house doesn't move, or as long as you're there, right? So here, I could say, well, now Einstein moved 1 meter to the left from where he originally was, which is great for me, but to you guys, right? For me, moving 1 meter to the left means it moves from in front of Audrey to in front of Gianni, right? But to you guys, if Einstein moved 1 meter to the left, where would he end up? In front of Emily, right? So we have to be careful with that directional system, and sometimes, we might have to be as specific as latitude and longitude. Sometimes we might not need to be that specific. It really depends on what we're trying to accomplish. Does that make sense? So what I'm saying is, what is the reference point or what is the directional system? Those can change based on the situation.
So is like the directional system like I live next to where?
Could be, right? Or it could be like, so if you live on Hilliard, right, you could say, all right, my house is one house. Okay, I'm trying to think of like, on Hilliard, if you go, my house is 3 houses closer to the rec center past the intersection of Hilliard and Bassett. Does that make sense?
Yeah.
So that would be true regardless of which way you were coming from.
Okay.
Right? You know what I'm saying?
Yeah.
But if you say go on Bassett, get to Hilliard, and turn right, you might not end up in the right spot depending on which way you were coming on Bassett from. You know what I'm saying?
Yeah.
So, you have what these are, the reference point and directional system, can change based on the situation. How specific they are depends on who you're talking to, who you're trying to describe, that kind of stuff. Right? Does that make sense? All right. And describing the position of something is great unless that thing moves. So, let's jump from here to here. Okay? So here's this iguana. Here's this iguana, and he's moving along these rocks. And you have kind of a picture of this iguana, but it's a little bit more detailed up on the board than it is on your picture, and you'll see why here in just a second. Okay? This picture shows the iguana moving from one spot to another spot. Its position is changing. It's not where it started anymore. It's in a different spot. Now, we don't just describe where it is, but we have to describe, well, it was here, but now it's there. And so the term we use to explain that or describe that is the displacement. I'll show you in a second. Displacement is the change in position relative to a reference point. If we go back to you giving your friend directions to your house, right? Your friend calls you up and says, hey, can I come over and hang out? You say, that's fine, but I'm at my neighbor's house that's 3 houses down the street. Maybe you already did.
Ask my neighbor.
He said, hey, can I come over and hang out?
That's so annoying.
No, I only got to. I don't even hang out with Billy and Jen.
Iguana. Walking along these rocks. So first, there's a couple of symbols on this picture that aren't on yours, but we'll explain what they mean here in a second. First symbol is this triangle. I believe we've introduced the triangle a little bit here, right? The triangle represents delta, right? It's Greek letter delta, and it represents the change in something. If we're going to figure out the change in anything, what do we need to know? Initial and final. Where did it start? Where did it finish, right? If we talk about the change in temperature from yesterday morning to this morning, right, which is pretty drastic, but we need to know what the temperature was yesterday morning and what it was this morning. Okay? Here, the delta is in front of an x. If we think of this as an xy coordinate system, an xy axis, right? If the iguana is moving horizontally, he's moving on the x-axis. So delta x represents the change along the x-axis. Okay?
So, like, if the iguana jumped, would it be delta y?
Could be, or if he climbs up a tree, right? That could be delta y. Yeah, right?
Why not like a diagonal?
That gets into two-dimensional motion, and we're not going to go there in this class, okay? But we could describe change on the x and change on the y.
So would it be like delta x plus 1, y plus 1, like that stuff?
Yeah, there's other ways you could do it, but we're not going to do it here.
We're not good.
All right, so we talk about the change in the position of an object. And in order to do that, we need to know where does it end versus where does it start. You'll see that you have space on either side of this picture. You're going to need it because we're going to do 2 examples here. So you might do this on the left-hand side of the picture, and you might do the next one on the right-hand side. Back one's fine. Back is fine too. Okay. So in this example here, right, the gecko, and you guys might want to draw this in on your picture because you don't have these details on your picture, right? This gecko starts here. Sorry, it's an iguana. I keep calling it a gecko.
This is a gecko.
I usually call it a gecko, but I've changed it to iguana to be, relevant to
Are
what
they
we're
both
talking
types of lizards?
No, they're both types of.
Maybe
All right, so where would we say that this gecko / iguana ends up? 84. Okay, so that means that the final position of this gecko is at the 84 centimeter mark on that ruler. Minus the initial position. Where did the gecko start on this ruler? Let's go 24 because that'll make our math easy. Okay? And so we run this through and we end up with delta x, or the displacement, being 60 centimeters.
How do you know where to take the measurement?
Well, in this case, we said it's always relative to a reference point. Okay, what's the reference point in this problem?
Stomach.
No. Nope. Where are we making all of these measurements from? Right there. Because the 24 is 24 centimeters from the beginning of the ruler.
Alright.
And the 84 is 84 centimeters from the beginning of the ruler. We don't always have to make the starting point the reference point. Sometimes it helps, sometimes it doesn't. Okay? So in this case, the beginning of the ruler is our reference point because that's what the ruler measures things from. Okay? So 60 centimeters, not where the iguana starts, not where it ends, but how much does it move? Okay?
But you worry about significant digits.
Yeah, don't worry about that for now. So, all right, ready to change?
No.
Get it.
Oh no, it's the other way.
It's gonna be negative.
So in this case, right, the iguana starts here, and it ends here. Because it's moving, we're still worried about its displacement, right? The change in its position. And we still are concerned with where it starts versus where it ends, or where it ends versus where it starts. So in this case, what will we say the final position of this iguana is? 14, I'm okay with that.
No, I mean like when you take it from like the gecko or whatever, like, you just choose a spot on the gecko.
Well, no, it's saying this is where he ends, right? I mean, yeah, where his feet, that's fine. Although this arrow is
Will
supposed to.
it, yeah, will like it always give us that arrow?
Yeah, I mean, I'll have some way to try and make it
Alright.
clear to you. Okay?
Is the reference point still 0?
This reference point is still 0 because that's where we're still measuring those distances from. Okay? And then, how about again, just to make our math a little easier, let's call the beginning point. Okay, it's at 78. I was thinking 79 because it might make our math easier, but 78 is fine. So now, when we do this math, we end up with what? Negative
You can't have
64. Okay? All right. Say again? Okay. So in this case, this is how far he moved, but it also is telling us what?
Change.
Yes, but what's different about this one versus the previous one?
backwards.
Different direction. Okay? Doing good.
I got this.
All right, hey, we'll finish this up tomorrow and get into speed and acceleration and all those fun things.